Hi, my name is Mouse. I'm an artist, and I'm going to help you learn uScript in 40 minutes. It really is just that easy. In this video tutorial, I'll be showing you how I created this scene in Unity using Detox Studio's uScript. We'll go through all the steps together so you can see just how easy this is to do with the right tools. You won't have to write a single line of code to make this. With uScript, you just draw shapes on a piece of graph paper. Flow charts that tell the game what to do. So, let's get started. First, you will need to download the geometry buttons example from uscript.net/docs. We will use this as a starting point so that we don't have to recreate the moving capsule player, floor, or pillars. Alright, let's create a new project inside of Unity. Don't forget to import uScript Visual Scripting Tool and set the proper location for your new project. Now that we have our brand new project with uScript, let's import the geometry buttons example package. Assets, import package, custom package, and then make your way to the file we just downloaded. Now that we have imported it, let's take a quick look at what's inside the example project. Double-click the main scene to open it. Let's press the play button and test it out. We have got a capsule that can be controlled with the arrow keys, some isometric geometry buttons that control the light, turning it on and off, a floor, and two pillars. With just a few tweaks, this scene will be great to test out our drag and drop script in. Let's get to it. It looks like we've got a warning. It's no big deal. Just a missing script component. Let's remove it to fix the problem. Let's clear the console, and then press play again to make sure that fixed our problem. Now that everything is happy, we need to add some cubes for us to play with. Game object, create other, cube. Our cubes will need to have the rigid body component attached to them so that Unity will know we want to make the cubes respond to physics. With the cube still selected, component, physics, rigid body. Next, we're going to need to set up our layers and tags. Click on Add Tag in the Tag pull-down. This will bring up the Tag and Layer Manager. Let's go ahead and name Element 0 Drag Me. Now, name Layer 8 Drag Plane. And now, Layer 9, GUI. Now we need to make sure the cameras are set up correctly. By setting the culling mask, we can control which objects are drawn by the layers we place them in. Because we don't want the GUI camera to draw anything but the GUI layer, we're going to make sure that's the only one that's checked. For our game objects to be culled correctly, we need to make sure that they are in our GUI layer. We're going to use tags to easily identify which game objects can be dragged by our graph. Let's make sure that our cube is tagged with drag me. Likewise, we need to make sure our main camera culling mask is set correctly. So we'll uncheck both drag plane and GUI. This will ensure that our main camera can't see the GUI buttons and that it won't see the helper objects we're going to be creating in our graph. Now that everything is set up correctly, we can duplicate our cube. You can activate snapping with the hotkeys Shift-V, and then Command-D to duplicate the cube. There's one last thing we need to set up before we're ready to go into uScript. Edit, Project Settings, Physics, the collision matrix. This allows us to pick which layers can collide with each other. I am going to go ahead and turn off all GUI collisions. And we don't want the drag plane to interact with any other layers but itself. The collision matrix is explained in more detail here in the Unity documentation. We're finally ready to launch uScript. Tools, Detox Studios, uScript Editor. There's some really good information here if you're just starting out with uScript, but we don't need it right now, so I will just go ahead and close it. Let's load the existing graph and take a look at what we already got with the example. You can zoom in and out with the mouse wheel. Hold Alt and left click to move to a blank area of the graph where we'll be working. We'll start by making a commented area to contain all of the named variables we'll be needing. You can right-click to quickly place any node or variable. By giving a variable a name, we can reference it from anywhere else in the graph. We'll be using this boolean to tell whether or not we have grabbed an object. The drag tags variable contains a string with the value drag me. If you remember, we tagged all of our cubes with drag me. We'll be using this string to compare the objects with the tag to determine whether or not we want to drag them. You can also add variables to your graph by clicking on their button in the Nodes palette. This float variable will store the height at which we want our drag plane to be above the floor on the y-axis. This variable will store a reference to the game object that we have currently grabbed. Unwanted variables and nodes can be removed by selecting them and then pressing the delete key. You can also use Control-C to copy a selected node or variable. Then Control-V to paste. The drag plane variable is going to store a reference to our active helper object, which is a plane that we're going to use to bounce raycasts off of. I'm just going to tidy up the graph a little bit so it stays easy for us to read while we're working. Don't forget to save your progress often. All of your graphs will start with an event of some kind. Think of the graph as a flowchart. This is the beginning. This is where you start, and you move through all the connecting lines, which stimulates the nodes to perform their tasks. All you have to do to connect nodes together is drag a line from an out socket to an in socket, or vice versa. Now that we know an input event has occurred, we can filter it to look for the right mouse click, which should read mouse 1. Most of the nodes are self-explanatory. This uScript event fires on graph start. That means when the game begins, this node will send a message to the next node connected to it out of its exit socket. The print text node will print a string to the user interface. The compare bool node will compare a Boolean variable, which is either true or false. Connect the variable you want to compare to the bottom of the compare bool node. In this case, grabbed. The input events filter lets us know when the mouse button is down, held down, or up. It's a good idea to use comments to help you visually structure and keep your work environment clean so you have an easier time reading what it is you're creating. You can check or uncheck these boxes so you don't clutter up your graph with unneeded sockets. The sockets are color-coded, so it's easy for you to tell what type of variable needs to be attached to them. You can see our graph is starting to show some structure. If we get an input event, and it is of type mouse1, which is the right mouse button, we then send that event along to the appropriate bool statement. In this case, the input down, we compare it to see if the Boolean variable grabbed is false, and then we pass it on to get mouse position. Next, we're going to use a raycast from ScreenPoint to determine if the mouse has clicked on something in the game world. A ray is like a straight line that we project until it collides with something. It'll then return useful information like what it hit and how far away the hit was, or the location of the hit. As we're wiring up the raycast, I realized that we forgot to include a camera variable for the main camera in our scene. So I'll go ahead and name it now and drag it up to my named variables notes in the top. We can work in any order. We don't have to go from start to finish. Before I forget, we need to check and make sure that the raycast is checking for collisions on the appropriate layer mask. This one should be set to default because we want it to test everything in the scene. Now that the raycast has stored in the grabbed game object variable the object that it's hit underneath the mouse click, we're going to test it to see if it has the tag drag me on it using the game object has tag node. If the grabbed game object has the drag me tag, we move on to the next step. The get components vector3 node will take a vector3 variable and break it apart into 3 floating point variables, x, y, and z. We're going to use the drag y plane to set a fixed height instead of using the height that we've retrieved from the hit location. Unity Engine.RigidBody is a reflected node that allows us to access the properties of a component on a game object. Here we are telling the grabbed game object's rigid body to move to a position, vector 3, that we've previously calculated. Now we are going to set the grabbed game object's rigid body useGravity variable to false by making a reflected instance that references that value in the game object in our scene. All right, just a quick recap. We've used the screen position of the mouse click to cast a ray through the camera and hit an object. We've taken that object and stored it in the grab game object variable, and we've passed it along to the game object has tag and tested to see if we've tagged it with drag me. If it's tagged with drag me, we take the hit location, we separate out the Y value using the get component vector 3 and insert the Y value, which is the height of our helper plane that we're going to be setting up next, back into a component vector 3. We then take that vector 3 and we set it to the move position of the rigid body that is referencing the global, that is referencing the grabbed game object. This will cause the object to move to that position while respecting physics, so it'll still collide with things. Okay. Next, we set the useGravity value to false on the rigid body of our referenced object that's stored in the grab game object variable. This will tell Unity not to process the effect of gravity on it. So that way it is weightless and it does float there while we have it grabbed by the mouse. Okay, so let's get ready to create our helper object. The drag plane will represent the third axis that we can't get from a screen position. On the screen we only have two coordinates, x and y. We can't get the z or the depth. So we're going to go ahead and artificially put a depth in there. So we're just going to fix the depth at the drag plane y height. Whoops. Remember, the color lets you know what type of variable you can connect to the socket. This requires a vector 3. We need to set the name to drag plane and the primitive type to plane. Grab the variable that we are going to store the dragged plane in. Now, we need to set the layer of our dragged plane to drag plane, so that way it isn't rendered by the main camera. We'll also need to increase the scale of our drag plane so that way it covers the entire screen. Next, we set our grabbed bool to true. This lets the rest of the code know that we've successfully done everything we needed to do to set up a draggable object. Next, we'll add the code that updates the position of our draggable object as we move the mouse. While holding Function and Shift, I can click on multiple objects to add to the selection. We'll copy many of the nodes we need from the Grab section because we're basically doing the same thing that we've already set up, but instead of on down, it'll be on held. We won't be needing the hit game object because we'll only be testing against our drag plane. We'll only let events pass into this section if our grabbed bool is true. We'll be setting the move position of our grabbed object's rigid body. So let's grab a copy. Let's review this section. We only drag an object if the mouse is held and the grab bool is set to true. This means everything has been set up in our grab section. We use the mouse position through the camera to cast a ray against the drag plane. That gives us our hit location. This hit location has already been adjusted because we set the hit plane's Y position using our variable. Now we just need to do a little cleanup when we drop the cube. On mouse up, we check to see if the grab bool is set to true. If it is, that means we have some helper objects we need to clean up. We also need to set the used gravity property of our dragged game object back to true. Now that everything's been cleaned up, we need to set our grab bool back to false, so that way we know nothing is being dragged right now. Now that our graph is complete, we can save our work and return back to Unity. Let's test our project. Uh-oh, it looks like we've got a bug. Don't panic though. Bugs are pretty common when you're programming. The good thing is, they always leave clues as to what it is that's causing them. If we examine our issues close enough, they'll tell us why they're there and how we can fix them. It looks like an axis is inverted. When I move forward, the cube goes backwards. Let's take a look at the code and see if we can't figure out what needs to be fixed. I remember when we were setting up the Get Mouse Position node, there was a checkbox for inverting the y-axis. Let's see if that'll fix our problem. Save our changes, and then we'll return to Unity so we can test our scene again. And there you have it. Drag and drop, without a single line of code, thanks to Detox Studio's uScript. I want to tweak a few things before we call this a wrap, because I'm an artist, and presentation is important. Ah, here we go. Now, our instructions should look like they belong in this example project. Let's go have a look. Hey, that's looking pretty good now. And this is just the beginning of what you'll be able to do now that you're learning uScript. It's easy. Thank you for watching. I hope you enjoyed my first video tutorial. And before you go, there's a few more things I'd like to show you. Remember the main camera's culling mask? Let's set it to everything, just for a moment. I want you to see the helper object that we created entirely in uScript and removed. As always, don't forget to use your hotkeys. They'll help you work faster. And please participate in the community forums. Our community is only as good as we are. Thanks for watching. I hope you learned a lot.